Okay, so my name is Jim McGann. I'm with Index Engines. I've been working on the Dell EMC relationship when they used to be EMC, for a couple of years. But we started working with them on a number of different use cases. I mean, our claim to fame is the ability to index data. Obviously, it's in our name. But what we've done is built it at a class of the enterprise to support petabyte class environments. So it needs to be very efficient, very high speed. It's not something like that's built on Elasticsearch. It's all built from scratch with our own technology. And indexing network data is easy. You can crawl through that and index it. But we've also indexed backup, as Stefan was mentioning, backup images, whether it be a Commvault or a TSM network or Avamar. So understanding those formats, getting inside there and indexing the contents of those formats. So there's a lot of different use cases that we've been involved with. A lot with Dell EMC has been around backup migration when a customer's migrating from an old TSM environment to Avamar or Networker. We can clean up that old environment, take over management of the catalog, access the data, migrate the data to cloud, get it off of tape and clean those environments up. We're also involved with Dell EMC in a number of personal data management, more the GDPR regulation. A lot of you guys are from EMEA, and well, even the US folks have that. But to be able to find personal data and to manage that effectively. So the different levels of indexing we do go all the way from full content that can find personal files and sensitive data, to metadata level content, to catalog level content, to managing catalogs. This piece that we developed has been in development, and a lot of the integration that Stefan talked about in the Vault has been in development for over a year or so. And it's really built to be a purpose-built Vault environment that will really support cyber recovery and support the analytics and so on. So when talking with them over a year ago, one of the areas they needed some support on was indexing to be able to look at the data, perform analytics, and which we added to our product. And on top of that, we added machine learning, and we also added some forensic tools to figure out what's going on. So the goal is, as you look at the data, to look at the integrity of the data and look at the quality of the data. I mean, a lot of vendors talk about moving a gold copy data off your network, and it's like, if you haven't analyzed it, you really don't know how clean that is. How much of a gold copy is that there? So, so they look to us to provide this analytics. We have a product called CyberSense that does that. The important thing to understand about CyberSense is to differentiate it is what it's not. So we're not saying this is a replacement to real-time protection. So you have a number of real-time protection tools, like the signature-based tools like a McAfee or something like that, that's really looking for very specific signature-based type infections. You have behavioral analytics tools, something like a Varonis, that's really going to look at unusual activity. They're not 100%. If they were 100%, we wouldn't be sitting in this room talking about this product today. So they have some levels of effectiveness, but they're not going to solve the problem. So the fact that there are flaws, I mean, something like Varonis, if it's a slow attack that doesn't set off these behavioral alarms, if the attacks, it doesn't really change the metadata in a way that's going to set off an alarm. I mean, the cyber criminals are getting very smart about what they do. So they understand these tools and they work around them. So these are not really looking at the data. So we're assuming that these have failed at some level and the data has been corrupted. So how do we find that corruption? How do we replace the files with good files? How do we recover from that and also provide diagnostics to be able to figure out what happened and what type of attack? So that's really what we are. So again, it's not a replacement for real-time protection tools. This is a new layer of protection on top of those solutions. So when you look at the attack vectors, what they're doing is really three basic things. Encryption of the data, corrupting the data structures, and deleting important data. We monitor attack vectors all the time and new ransomware all the time. There's usually about 1.5 to 2 different new ransomware threats that come out every day. There's actually a ransomware as a service vendors that you can actually partner with them and they'll build a ransomware for you and split the bitcoins with you and execute on it. So which is the world that we're living in today, which is why what Stefan and Dell EMC is doing is pretty critical. So what they're doing is really three basic things. If they build a new ransomware tomorrow, which they will, they're really just going to rehash an old ransomware and just change the name of it. So it's a new named ransomware, but it's doing the same old thing. So in terms of looking at the data, and when I talk about our machine learning and us training the behavior of what these ransomware attacks are doing, it doesn't really learn anything new because it's the same types of attacks, these three. So by looking at this, and what we've done with CyberSense is creating observations. So when cyber recovery creates another replication into the vault, we'll do the analytics, which is an observation of the data. We look at it. So let's look at it and compare it to what's happened in previous observations. So as you're looking at it on a continual basis, every day, every couple days, every week, whatever you decide your analytics policy is going to be, and you see something wrong, or CyberSense says, hey, something has changed dramatically about the data. So you may be looking at Word documents that come in last week and they look fine. Then suddenly we have an entropy algorithm that'll say, hey, the entropy score dramatically increased on that Word document. That's a flag. Something may have happened there. So as you're looking at those observations and you see something that's wrong, your recovery from that could be just within a single backup cycle. So you can use your backup processes and use cyber recovery to recover from that, say, hey, these files, these databases, something happened to them, replace them with the last good copy. So it really extends the use case of disaster recovery and allows you to recover from this as though it were any type of attack or disaster that exists there. So the idea is that you're looking at it on a continual basis. So CyberSense, there's a number of different things. What Stefan presented really is a specific implementation within the vault. The architecture of what we do could be run in a number of different environments. So the first step of what we're doing is doing the analytics or creating the view or the observations of the data. And those are set up through scheduled scans. Stefan demoed that in the demo. A lot of that's automated, within the cyber recovery product, so it's all a self-contained process. We can scan, however, different sources. So we can scan primary storage, so you can select specific file shares. We can scan production backup, or the cyber recovery vault. A lot of customers we talk to prefer to have an isolated, dedicated environment that's really focused is the specific use case of preventing or recovering from cyber attacks. So there's different scenarios that can be implemented. They could all be different combinations too. So if you want to put your crown jewel data in cyber recovery vault, but then you want to check the integrity of your legal team documents, for example, you can do that as well and just run scans on those documents out on the network. So the scanning, where it happens for us, for CyberSense, doesn't really matter. It could be anywhere. It could be backup data or just loose files on the network or databases. So as those scans occurred, every time there's a number of this more than 40 different statistics that are generated. Customers are saying, I don't want to look at these statistics all the time and interpret them and figure out what's going on. So here we apply the machine learning on top of those statistics to say, look at all the statistics, look at what's happened, compare them to previous observations, and come out with basically a red light, green light, or a yes or a no. And that's the alerts that Stefan was just showing there in the cyber recovery vault. It's going to come out with a red alert saying, something looks strange here. Looks like we have a problem. Or it's going to come up with a green light, which in that case you won't get an alert. Everything looks OK. So the real use cases we're seeing is really about the integrity of the data. By having analytics and machine learning looking at your data on a continual basis, on a frequent basis, different observations, you can validate the integrity of that content. So there are some vendors out there that are just migrating data to the vault and saying that's your gold copy. If that data is already corrupted, you're basically protecting corrupted data in the vault. So the question we get all the time from customers is, how do I know I haven't already been corrupted? How do I know the data is already not clean? This is the answer to that question. We can tell you that. Supports recovery. So we talked about getting data out. I mean, one of the values of the CyberSense product is what it indexes a backup image, Avamore, Networker, TSM. Without having the backup software in the vault, we could extract individual files and so. So Stefan mentioned one of the projects they're doing in Israel, which is doing further analysis on the data. So they can request to CyberSense saying, I'm really concerned about my DLLs or my EXEs, my custom applications I built. So every time there's a backup into the vault, CyberSense extract those out and then feed them to this other tool to do deeper analytics on that content.
So because this is machine learning, the more files you give it, the better it gets at it?
It gets smarter as it goes.
I was trying to avoid that word, but yeah.
Better.
Hard to,
More
right?
It gets more better.
It does.
Yeah.
So the idea is that as you have more and more observations, one, it's going to see how data is changing, and it's going to learn as it goes along and get smarter and smarter.
And do you collect telemetry across customers so that it learns that way as well?
We do not today. We do not today. I mean, that's something we're looking at. Hopefully customers will share that because it's not.
Because then you can let your neighbors get corrupted first. Like literal neighbors, not.
There you go.
I'm serious.
There's a benefit. No, I think there's definitely a benefit in sharing that and creating a community around that. So
No doubt.
the other area is protection. So something like GDPR, has a lot of those requirements in there for data breaches and protecting that content. So this allows companies to really put in an environment that will support those kinds of applications and be able to understand, how the data is being managed and if it is being infected to kind of spearhead those in advance. So I think when a regulator comes to call for something like GDPR, you can say, here's our cyber recovery vault, here's the analytics, here's how we're analyzing it, and we're protecting it much better than we had before, much better than our competitors are doing that. So there's definitely value add. And I think there is value, there is the use case of putting CyberSense on, out on your network or on your production data domain environment, but creating an isolated environment that's built for that purpose. If you're a company that is going to be heavily audited and heavily attacked, that's, you need to put up, the munitions to be able to attack that. That's the use case. So there's a lot of different things that we can do in terms of how we scan the data. Unstructured files, I think some of the customers we talk to just think about putting in things like databases in there. Let's put the SAP databases into the vault because that's the stuff, the mission critical stuff. But why wouldn't you check the integrity of key documents, legal documents, and agreements and look at that? You may not need to do analytics on it every day. You may need to do it every week or so, and look at that content to get assurance that data is safe. So we support unstructured files. We support databases. So we're going to look at pages of a database specifically for encryption. So you can see an entropy score of a page of a database to see how that changes. So if you're putting in your SAP your DB2 database in over the past couple weeks, and then suddenly it says this page of the database suddenly had a significant increase in entropy score, that could be indicative of an encryption of that page of the database. At that point, red flag goes up. Do some further analytics on it to see what happened, and if there is an attack or a corruption on there, go back to your last good backup, replace it with the last good copy, and no business interruption there.
So you've listed relational database here. What about non-relational or?
Right now we support these. Yeah.
Okay.
Yep.
And on the support level, talking about files, that implies file systems. So I imagine we have the standard ext234, NTFS. REFS, I have seen.
Yeah, so we're looking specifically at the files. So we're looking at the actual files and reading the header of the file and looking inside the content of those files.
Okay, but if I'm taking VMDK, my file is the VMDK file. I have to open that up and interpret the file system to get at the files.
Yeah, we support VMDKs going inside there and interpreting that. And interpreting
PHDs as well?
Yeah, so things like TSM, we can go inside those TSM databases and index the contents of TSM and so on.
The question would be then, if I pull up a VMDK file, I need to know how to read and mount that file system.
Right.
And I've seen situations where some of the more exotic Linux ones simply aren't there, ZFS being a big classic. REFS had limited support.
We have a support matrix that details what we support.
Okay.
I mean, obviously the devil's in the details there on what we support. So yeah, we can provide that to you.
Okay.
So backup data support, like I said, we get inside these backup containers and index that content. So NetBackup, TSM, Commvault, Networker. Avamar is new for us in terms of supporting that. So the idea of customers are using these different applications to back up data into the vault, or if they're doing it in production, we can index those backup images. So the idea, again, is in the vault, you do not need to have the backup software. Index Engines just gets presented the M tree from the data domain in the vault and says, hey, that's Networker. I understand that. Get inside the Networker, index the content that's in there. So if it's an Exchange database, it'll go inside Exchange and index that content. It's like peeling the onion, going layers deep into that content. Let's skip this one. So yeah, one of the things that Stefan mentioned is the hardware specs. So we have specking tools that'll basically figure out what kind of resources you'll need in the vault. So it's all virtual servers. It really depends on how often you're running analytics and the volume of data coming in on a daily basis, for example. So we have customers that are putting in 10 terabytes a day or 10 terabytes a week, and other customers that are putting in hundreds of terabytes a day or a week. So it really depends. The beauty of the CyberSense product is you can stack up a number of virtual servers, and they could just all run together and work through the data to make sure. Obviously, after the replication is done in the vault is really sitting idle. So Index Engines or CyberSense has all the time before the next backup to just process the data and perform the analytics. So, depending on the volume of the data, we can spec out the number of hardware servers in there, but they're all virtual servers, pretty straightforward, right? And we are releasing our product as a Docker, so it's just easy to deploy, set up. It's already pre-integrated. It's just a matter of setting up the jobs and configuring it, and then it's good to go. So this is the workflow. So the initial scan, again, in this case, we're going to scan the vault. That's set up on a scheduled basis. Think of a scan as an observation. So we're just looking at the data. We're just going to look at it and just see what's happened to the data. After the scan occurs, there's a series of analytics. So we're not going to expose all the details of what we're doing here because that's going to get out to less friendly people than are sitting in this room. But there's 40 or more statistics that are generated. So we're using entropy as one. So entropy looking at the random disorderness of files or a page of a database. So if, for example, you see a Word document, like I said, has an entropy score of 50 or 60, typically looks normal. When one of those documents becomes encrypted or partially encrypted, the entropy score will go to 99. So the entropy score is from 0 to 100, 99 being, you've got encryption. So we look at encryption, we look at file similarity when files suddenly become very dissimilar. So again, as you said, it gets smarter because as it's looking at different observations, it's looking for changes that are indicative of a cyber attack. Not what users are doing to files. If a user goes and edits a Word document, you're not going to increase the entropy score to 99, right? Looks for file corruption. So when they strip out content, it becomes 0-byte character file. Look at mass deletions or mass creation. So some of the attack vectors are going to go and corrupt files so much it looks like a deletion. So there may be 1,000 files were deleted, and then it'll say 1,000 files were created at the same time. So that looks strange. If a user does go and say, I'm cleaning up and I'm deleting 150 files, how do we not trigger on that? It's looking at all the other statistics and looking at, was there encryption involved? If there was 150 files deleted but not 150 created? So look at everything and look at everything that happened to make a determination of, did a user do something strange or is that indicative of an attack? So there's over 40 statistics that are generated every time there's an observation. So, and then customers have said, I don't really want to analyze those statistics to figure out what's going on. So what we've done is we train using the machine learning here. So the machine learning is trained on all the common ransomware attacks that exist out there. So one of the questions you will ask is, do we have to constantly update the Index Engine software to update the machine learning? Like I said earlier, the attack vectors and what they're doing to the data hasn't changed. So as we educate the machine learning, it's not really learning anything new because it's like you're doing the same thing. You're doing encryption, you're doing deletion, you're doing corruption. We've seen all that stuff. The only thing that would be missing would be names of the ransomware. That there's a new ransomware tomorrow and you haven't updated the software, it won't have that name in there because we can search and say, show me files with a known ransomware extension. Those would be missing, but there's other ways to get around that. So the machine learning is going to look at these statistics that are created and come up with a deterministic, red light, green light. Green light, everything looks okay from the last observation, everything's fine. Red light, there's something suspicious that happened, right? And that's the part that's integrated that Stefan showed you, and I'll show you more detail on that. And the beauty of this is it repeats. So yes, it gets smarter as it repeats, but you're doing continual observations of the data. You're constantly looking at it for unusual behavior. So if you do get that red light situation, we provided a series of forensic tools to be able to diagnose what's happened. So we're just not leaving you saying, hey, these 1,000 files look like they've been tampered with. Good luck, you're on your own. Because if you replace those files with the last good copy, you've still got the ransomware or the malware sitting somewhere out there on the network, right? So how do we solve that? We'll talk about that. But as I mentioned earlier, is like, how can you use CyberSense to kind of look at your data when you first populate the vault, and you're creating this gold copy and kind of creating this baseline of the data integrity, is there's a number of reports. This is a mock-up of a dashboard that you can do, is looking at different types of reports. And I think this is interesting for customers, and we constantly get the question is, how do I know that when I'm populating the vault, the data isn't already corrupted? is there's a series of reports that you can go through here. And again, we have partners that are looking at building this kind of thing to provide this as a service. Is let's look at the data integrity and help analyze this. But on the top center there, you could look at the mean or the high entropy score per server. So if you just want a quick look at it, you can point to a server, scan the server, and say, what is the mean entropy score of the content of the server? So there's different thresholds here that if it looks high, or if it's changing and increasing, you know that there may be some issues with it. So one of these servers here, and then also the high score. So there's 2 servers that have an high entropy score of 99. So that's malware corruption. They've been encrypted. Those files have been corrupted. And the other files, the mean entropy scores on there are very high as well. So looking at user share B is where you want to start. Is let's look at that further and figure out what's going on there. You could look at known ransomware extensions. So here you can say, show me all known ransomware extensions like .lol, .loki, .encrypted that are out in the network. And then combine that with the high entropy score. So there's some of the malware will use the extension .run. There is a valid application that has an extension .run. So how do you know it's valid or not valid? It's like, well, show me the .run extensions with an entropy score of 99. And those are the ones that are probably malware because there's some high encryption there. Or just look at file types with an entropy score of 99. These are the ones that if you haven't updated the software and there's new malware out there, this would uncover that, finding, there's a file type .ddd or .abc that has high entropy score. Those are suspicious files. Or looking at corrupt files by server. So you can kind of do an initial assessment of this data and create a baseline to say, hey, there's suspicious content out there using these analytics, right? So there's also other products. There's quite a few products out there. I mean, everybody's talking about machine learning and analytics in this case because it's a great buzzword, right? So we've looked at the important thing of what we've done with CyberSense is we look inside the content. So instead of just looking at the metadata. There's a number of other backup vendors that are just looking at the metadata. So what we did is we did a test and we turned off the content and just say, let's just do the analytics on the metadata alone and see what kind of results we get. So what we did is using metadata-only analytics, we basically saw a detection rate of about 11%. So they had the detection error rate of about 11%. Turning on the full content, we had a detection error rate of about 0.5%. So just looking at metadata, it was a 22 times higher failure rate of finding these infections. So an example would be something like, corrupted files with corrupted extensions. So they've ripped out the extension. When CyberSense looks at a file, it reads the header of the file. So it'll read a Word document. It'll read the header, go inside the content, read the header, and say this is a Word document, but the extension does not match. So file type mismatch. Metadata, you're not going to be able to see that type of corruption. Or partial encryption when they go inside of a Word doc and partially encrypt the internal contents of the Word doc. So there's quite a few corruption or attack vectors that require full content. So I think one of the things that's important to look at is when you look at, people say, oh, we do machine learning and analytics, is ask the questions. Are you going inside and looking at the content? So the architecture of what we've done is to be able to scan inside backup images inside the content at very efficient, very high speed rates to be able to support this use case. So I think these are interesting tests out there, and I think if you look at putting a malware detection analytics out there with a 11% error rate, you're really not protecting yourself, right? So in terms of the forensic analysis, so what happens when you do have this red light situation? And this is an area I think that we can definitely work on more in terms of the cyber recovery product of adding more knowledge into that solution. But when you do have that, there's a 4-step process. Step 1 is notification. So if you're using cyber recovery, you're going to get that alert in your dashboard. We also have the ability to send out an email alert that there's an infection. A series of reports, which I'll show you, which is going to give you an understanding of what's happened. Some diagnosis, looking at event logs, which I'll tell you what we can do there, and then steps to recovery. So this is the email report that could come out. So basically what you're looking at here is an infection found, yes or no. So infection found, no, means the data looks fine. This is the same alert that gets fed through APIs into the cyber recovery dashboard. that'll trigger that alert. Same thing. So in this case, infection found says yes. So what comes with that is a detailed report. This gives you a little bit of a view inside all the analytics or the statistics that are generated. So you can see on each observation, you can look at the deleted file count, deleted mean entropy, creation file count. So it's all these are all the analytics that have been customized and created here, looking at the entropy sizes and so on, looking at file extension mismatch and so on. So it creates these different scores. So for some of our larger customers that have cyber teams, they could use all these analytics and build their own tools on top of this to kind of look at this data and analyze this data.
And this is running on the primary data domain or on a separate appliance?
It could run either, but in this case, it's running inside the vault on a separate.
In the vault.
In the
so
vault.
How's it sending the email?
This is well.
We have that SMTP mailing mechanism, so you would basically ship it to a mail server that you configure. If that's not secure enough, you can do a diode, data diode. That's very secure. Otherwise, you have to go in the vault, and then of course that's a it's a non-issue, right? If you do this in production, which you can. But the nice thing is you have a static vault, right?
Yeah, so, no, I get that. Just trying to
but it's going to go
find out where the openings are, where the surfaces are.
It's going to feed the dashboard. So if you're visually looking at the dashboard, you'll see the alert through the dashboard. So you can see all the analytics, file corruption, file type mismatch, known ransomware extensions. So this runs continually. So what it does is using the machine learning, it's going to look at the behavior of those statistics and say, I know the attack vector that does this kind of stuff. So what we feed in this report here is the attack vector. So this is attack vector number 4. This is based on this. So attack vector number 4 is encryption with a change in a file extension. That's the most common attack vector, obviously. So we have, and this is parts that we're automating here, but we have listings of up to 23 different types of attacks, different levels of how they attack the data or corrupt the data. Of the 23, these 6 here are 99.9% of what they do. Of those, number 4 is about 70% of what they're doing. Is really strong encryption with a no-known file extension. So basically, machine learning has looked at all those statistics, come back and said, you know what, you got attacked. It was attack vector number 4, and this is what it's doing to your data. This is an area that we're actually improving upon. Also on that report, we're going to send you the list of corrupted files. You could also use our interface. So that's the question of in the vault or not in the vault. You could use our interface to run a series of reports that are linked to those types of attacks. So show me all files that were recently encrypted. Show me files that recently had change of extension of file extension. And you can run those reports. Here you can see a listing of the specific attacked files, the breadth of the attack, how bad it was, the location, the type, the file owner. So this is where if you're going to do recovery, these are the files that need to be replaced back out there because these were corrupted, right? Then beyond that, what we do is we are indexing the Windows event logs. Right now we're supporting the Windows events logs initially. So the Windows event log, you can say look at these corrupted files. You can look at, sorry, it's a little fuzzy here, but you can look at who was the last user account that changed that file. So if 1,000 files were corrupted, you can look and say, who changed those 1,000 files and corrupted those? Oh, it was all John Doe. So John Doe's account in the network has been attacked and is being used to make those modifications. We also will identify the application that made those changes. So 1,000 files were encrypted. You can say, who did that encryption? Oh, it was John Doe's user account. What is the application that did that encryption? That's going to be your malware, right? So these forensic tools, and a lot of this is going to be automated in terms of you'll just get a report out. Here's the files that were encrypted and the user account. A lot of that can be automated, but this is what we're doing today. You have these forensic tools that'll basically come and tell you, these are the bad files, you need to replace them. This is the user account that was used to make those modifications. And this is the application that did that deletion or did those encryption of those files. So obviously, that's where your malware is. So it gives you these forensic tools to do an investigation to not only recover and replace the bad files, but also diagnose what happened and actually go after that malware. Does that make sense? Head nods yes. Or?
Still looking, a lot of this stuff is going to have to be pulled back from endpoints, which currently generally don't end up hitting on the data domain backup cycles for most systems.
Yeah.
So are there conduits into this to get some of that data off the endpoints? Because biggest problem I see is a classic, if we're looking ransomware attack, is we've got the server, we've got the infrastructure really well covered here. We've got a good plan of bring stuff back online correctly, but I don't see the interaction with, well, I've still got 5,000 Windows notebooks out there that are all quite happily encrypting anything they can get their digital paws on.
Completely a valid point. So we're looking at stovepipes, right,
yep.
in some level, right? And what we haven't seen so much to date is doing this type of work even in a backup, which is, in a backup set, which is mind-boggling, right? So this is why we're so excited about this. Forget about the vault. I mean, just being able to do this in the backup and being more content aware. Yeah. How cool. Now it's still disaggregated. So, if we have the mechanisms and you have something like an eye sensor, that a box that can aggregate, and you feed this type of information into a cyber operations center counter threat unit like SecureWorks, now you all of a sudden can form a picture. And they're the guys that actually, have the network effect. To your point, they don't monitor many customers. That might be a nice way to bring it together. So in other words, would SOC integration be a play and something to look at to bring in sort of more of a unified view? And the answer is yes. Yeah.
But your goal here is, you have a focused goal on this is an infrastructure tool for the moment. Yeah. And we'll look at interacting with other players in the infrastructure later on.
Yeah, you got to start somewhere, exactly. We wanted to add that piece.
So you aren't being ambitious. We want to solve all of this in one shot.
Yeah, because then you end up doing nothing. I mean, when you look at sort of like, there was a lot of good work we put in to get this workflow right and get to the level of automation. And then again, we wanted to be mindful not to replace detection tools, but we wanted to give you some awareness to make smarter decisions, because everything that Jim talked about it's all about find the right copy, trigger some proactive actions, and then eventually you'll bleed into that cyber team, right?
Yeah, exactly. The other quick question is the index engines component. I'm assuming there's a cost associated with that part?
Yep.
Okay.
Yep. Yeah, so we
sold separately.
Sold separately. We charge by capacity, basically.
Okay, and now capacity being such a fuzzy issue when I'm dealing with backups that are compressed and deduplicated, and
so we're actually figuring out what the simplest way is right now. We're feeling our way through that, but there's a lot of different scenarios. But we want to make this a component that's it's obviously integrated, but provide tremendous value. What you're going to get for that, I think there's definitely value on top of the cost of the vault. Yeah. So we're working our way through some of those issues, but I think there's, it's going to be able to help just define the integrity of the content and to be able to say, my vault is secure, the data is secure, and I've also done enough analytics to know that the integrity is there.
Yeah. No, the value proposition.
So the value proposition is there. So we're still working through some of those issues because there's really nothing else in the market that does something like this in terms of looking at the content and doing that. So.
But you should consider charging nothing for the vault and then a whole lot of Bitcoin to get your data back.
I like the way you think. Isn't that true, right? Sales, where do they make money? It's all about the analytics.
You're just making the ransomware white.
We could do that.
Anyway, that would be evil Karen's business model. So one of the questions I had though about this, the ML technologies, like obviously that's something, like I said, it's running on the vault, so it's an application running on your vault. Like it seems to me there's a lot going on inside the vault that could also be, exposing risk to the vault. Right. And that's where I'm kind of getting lost in the where things are happening and where the doors and windows are on the vault.
Well, once the vault is isolated, I mean, all that activity inside the vault is protected.
Yeah.
The fact that, first of all, we're doing the analytics on the backup image, so we're not rehydrating the data out of that image, so that's secure. I mean, so the malware doesn't get a chance to execute any further.
Can I maybe chime in? I think because typically I think what we have with ML and sort of these scenarios, you need a pipe.
Yeah.
Right? And that's not the case here. What happens is it's trained offline.
Yeah, I got it.
And then you do a secure patch, so to speak, and then you get the benefit of the more aware.
Okay.
So that's a way to deal with it, because otherwise you're absolutely right.
Yeah.
Then you have to dial.
Yeah, and it's all a matter of doing the cost-benefit risks, right? And the better, the more benefits you get, the more you have to up one or both of the other things. The other is, the other thing we know about a lot of these massive compromises is that notifications aren't enough. So you talk about a dashboard and an email, and we know emails get ignored and people get over alerted. So is the expectation that these notifications would feed into another offering, service, product, third party, whatever, that would manage the responses to these reports?
So yeah, we can't talk roadmap, right? But if you think about it, you're onto something here, because this is where I mentioned that example iSensor. So think of it as a collection utility that SecureWorks would use, and then your endpoints would feed into that, and a lot of those signals will then end up in their counter threat unit.
Yeah.
And that's the tricky bit, because we'll add some signals, but if you have so there was an interview, SAP, 500,000 signals per hour.
Yeah.
So you sift through that, that's impossible, right? So their value proposition is, we're a network, this is what we do. We're the data scientists. We're not only monitoring you, but the others. So that integration makes complete sense.
Yeah, and I always come back to the Target thing, right? That went on, or other dwell time breaches that went on for years, and people were just ignoring the alerts. That's my biggest fear as part of risk management is, how do we make the risk management people understand risk?
You can only give them so much information. But we're talking to a lot of partners that are doing this as a service, that's their job and dedicated job, and they'll constantly monitor that data. I think for small companies, it totally makes sense, even for larger companies, to be able to do that.
Well, they might have an MSP that is managing their
business model. They go from 5,000 signals down to 5 things you need to actually take action on. That's very, very powerful. Right?
Okay.
Yeah. Very good point.
So we're getting close to the end. I think I can go through the workflow here. I think Stefan went through this a bit, but the idea of the cyber recovery vault is, again, to isolate it off the network. Again, all the integration that has been done is when you do a production backup, and then the cyber recovery vault opens up the replication port, replicates the data, closes the port, and then applies retention lock. All that in the bluish gray hours is all coordinated by the cyber recovery product. All that has been integrated into the product itself.
Just one clarification, it might be deceiving. We're not opening the replication port on the production. We're doing everything inside. So think of it as a pull, right? Because otherwise you would, to your point, have that attack surface. Minor,
right. So at that point in step 6A then once the replication is complete and retention lock is applied, notifies CyberSense that that's done, and CyberSense goes into action, indexes the backup directly, creates the analytics, and then kicks out the report either to the cyber recovery in the vault, or it could go outside the vault, either way. And again, this environment is all integrated, all plug and play right now. So if you wanted to deploy this in the vault, just using a Docker, you would put the CyberSense product in and set up the jobs, and you'd be pretty much done, right?
We're seeing switches here with that, and there's a pseudo firewall in the middle. Can those replication rules run through a netted interface?
No, we handle on the target. So we deal with the Ethernet interface on the data domain.
Right.
That's what we manage.
Okay. But can I put a firewall in between and have NAT?
Yeah, you can do deep packet inspection. Yeah.
Okay. Yeah. No, that's just thinking from that isolating stuff. It's not perfect, but an extra NAT layer would make getting in that much more difficult again.
Yeah.
And so CyberSense also has the ability, if there is corrupted files or files that wanted to be analyzed further. So I think, as Stefan mentioned, the group in Israel is looking to CyberSense to say, you know what, pull out DLLs or EXEs or specific files that I want to make sure are intact, and we could extract those based on request. And everything that we're doing in here is through APIs. So we could extract those on request to internal storage for further analysis. And that's the workflow that Stefan alluded to is doing further detailed analytics on specific files using signature-based analytics and so on. So I think the enhancements that are going to happen in the vault are significant. It's purpose-built to do this and apply as much analytics on top and automate as much of the process as possible. So you just get these alerts whenever there's a problem. Otherwise, you have the confidence that the data integrity is there. So
how often are your updates to the engine?
We update our software pretty frequently, every month or so.
Does that require you to rescan everything that's in the
vault? No, not at all. No. Yeah, so the updates here are going to update, fixes and patches, but it's also going to update the new names of the new ransomware and stuff like that. So, So obviously the key benefits are really looking for any kind of corruption. Again, this is not a replacement for real-time protection. This is an added layer of protection on top of it to say, let's assume that your data has been corrupted. And let's figure out where that corruption exists, find it, replace it with the last good copy, avoid business interruption, and then provide forensic tools that's going to be able to say, hey, let me figure out who did what here, which user account was breached, and which application or executable was doing that destruction on the data. So it's, we think that on initial passes on the data, we see 95% accuracy of detecting malware. On subsequent views, observations, as you mentioned, it gets smarter. We're seeing up to 99% accuracy to find malware that exists out there.